Hello everyone, welcome back to the class, and this is the third class of the chapter, that is electric charges and fields. So a small recap of what all we studied in the last class, that was about the Coulomb's law, and we also studied about the vector form of Coulomb's law, and the expression for that also was given, and this is how you have to write the Coulomb's law, the formula of force in a vector form. Next, we studied about the principle of superposition. So if I consider many of the charges over here, and these charges produces electric fields, and those electric fields exerts force on each other. This is what I had told you. And that force, if I consider many of the charges and the forces which they exert, then we are going to superpose, in the sense we are going to add it individual forces, and we are going to get a net force, and this is something called as principle of superposition. And next, we also studied about the electric field, and it tells you about it is a region where charges experiences a force. Yes, I told you, if I go to a minute thing, that is your atom has got many of the small particles, electron, proton, neutron, and those have got some charges except your neutron, and those charges, which is a fundamental property, uh, exerts some forces on another by producing electric fields, and this is something called as the region where charges experiences a force, and this one is your electric field. And not only that, we also studied about the expression for the electric field we understood, and how is it the forces and the electric fields are linked with each other, and this is the formula which tells you F is equals to Q into E, and the SI unit of this electric field is Newton per Coulomb. And we studied about the superposition again, in the concepts of not the force but the concepts of electric fields. So a charge produces a electric field, and the total electric fields of every individual charges is given by this formula. E is equals to E1 plus E2 plus E3, and goes on. So if I consider a big particle or a big object, in that there are several millions and billions of atoms, and those carry some charges. If I consider Q1, Q2, Q3, these charges produces fields, and these fields are added, and this is something called as principle of superposition. And next, we studied about the electric field lines, and we studied about the direction also. If I consider the positive charge, according to the concepts of electrification, it is a removal of charge. Which charge? Electrons. So you get positively charged. If I see, you can see that the electric field lines are radiated outwards, the direction is outwards. Now if I consider the negative charge, you can see the charges are the electric fields are inward. It is directed inwards for negative charge, and it is radiated outwards for the positive charge. This is what the direction tells you, and it is just for our convenience the directions have been given. And going on to the further, we studied about the properties of field lines, which tells you that it originates from positive and terminates at a negative charge, and they never intersect. They do not create any loops. They are continuous without any breaks. So this is what we studied in the last class, and in our today's class we'll be studying about another concept that is a very important concept for you. That is something called as electric flux, and this electric flux, the concept is given just to derive few of the derivations very easily. So this is the basic. If you learn this carefully with very intelligence. If you understand what is it during the derivations, you would find the concepts very easy. Okay children, now if I consider the definition of electric flux, it tells you that number of electric field lines. So fields are produced by charges. Okay, number of field lines pass normally through a given surface, normally in the sense perpendicularly, okay, is called as electric flux. So I would give you the explanation for this. Before that, just see the SI unit of the electric flux is Newton per coulomb meter square. Okay children, now going to the explanation of electric flux. So this is the dimensional formula, please make a note of it. Now going to electric flux explanation, I have just written it and took a picture of that so that I can make you understand very much clearly. So now what are they saying? If I consider a two-dimensional plate, so this is the surface I require. Okay, so if I keep a plate in this way, so just imagine in two dimension. So if I consider case 1, so before that you should know what is the formula of electric flux. Okay, so electric flux is nothing but e into delta S cos theta. So you have got one trigonometric component also. I would tell you why only cos theta is used. So first thing is to, before going to the cases, first you should understand what is electric flux and the formula for that. It is a electric field, that is E into the surface. So if I consider this plate, okay, on this surface, I would just make the electric field lines to pass through the surface. You're getting my point? So now, and on this plate of the red pen, I have written a unit vector, a direction vector I have given, that is n. So this direction vector and the fields are parallel to each other. So hope you're understanding that the electric field lines and the red color one, which I have given a direction vector, it tells you about that the angle between these two is, they are parallel and the angle is 0 degree. Okay children, now if I consider, just say theta is 0, so what is cos theta? It is 1. So what would be the formula for you? Will the electric flux would be 0? No. So cos 0 degree is 1, then phi is equals to E dot delta. Yes, it means that practically you can see that on this surface many of the electric fields are passing. But if I consider the equation calculated, yes, you can find some electric flux through it. And you can see through this equation and through this practical representation, both are tallying. So through this surface you can see that the electric flux are there, and through the equation you can see the equation has not become 0. It means that some flux is there, electric field is passing normally through the surface, it means. Now if I consider case 2, okay, yeah, I what do I do? It was in this way, I would just tilt it. The surface is like this now. Okay, now if I consider the electric fields moving through this, the surface which was like this in the case 1, I have just made it in the x-axis. So you can see that this surface is downward now. This direction vector has come down. Just take a plate which was like this, you just tilt it to the ground and you would understand it. Just imagine in your two-dimensional way. And now if I consider the electric fields, they are passing, but it is not touching the surface. Which surface? This surface. The electric flux is not touching this surface in the case 2 because it's been tilted downwards. So you can see that through the equation, electric flux is equals to, what is the formula? E delta S cos theta. So what is the angle between the direction vector and the electric field? It is 90 degree. So cos 90 degree is equals to 0. Phi, the electric flux is 0. Yes, it is proved, because electric flux is moving in this way, but it is not moving through which surface? This surface, if I consider over here, because this is not in this way but it is tilted, and your direction vector is downward. And yes, here also you can see that there is no electric flux passing through the surface, and electric flux through the equation is also 0. So both have been tallied, both are comparable. Now if I consider, why don't we use sine theta in the equation if the electric flux equation was, just imagine, if it was phi is equals to E dot delta S sine theta. If I consider case 1 again with this picture only, if I consider, so sine theta. So what is the angle between the direction vector and the electric field? It is 0. Is it? So what about sine 0 degree? It is 0. Now what would be the flux? It is 0. But do you find the electric flux 0 over here? No, because many of the electric fields are passing normally through the surface, and this practically it's wrong as I have written here, and through this and this you are not able to tally each other, and that is why we don't use sine theta, but whereas we are using cos theta here. Hope I made it very clear to you. In the same way, if I take this one and this one, both are not comparable. They do not tally with each other practically, theoretically. That's it. So next, I hope I have made it very clear to you. Electric flux means it is nothing but electric field only, children, passing through a surface. That's all. Very easy it is. You have to just imagine the concepts. Next, going to another nothing, it is the electric field intensity. I have given the formula again. So phi is equals to E delta S. Delta S means, S means surface only, but delta means small surface. And what is this? Cos theta. So it is the angle between E and normal to surface. So what all I told, the whole story about it, it is nothing but the about the formula, how you got it. Why cos theta only? Why not sine theta? This is what I explained in the previous slide. Next, going to another concept. This is a very important one, where you will be finding this in every derivations in the furthermore slides or the lecture what I gave you. So this is something called as the electric dipole. Okay, so if I consider this electric dipole, it is a system. You can see here it is a system of two and two equal and unlike charges. So you can see that uh, negative q and positive q, two charges are there. So two charges, in the sense you should understand that two particles are there where the charges on them is positive and negative, and they are equal. So can you find anything, any number next to this q? No, right? So 2q, 3q, nothing. You're just finding it is minus q plus q. It is something that only 1q are there. So distance between these two is 2a. So one thing, why do I tell you it is 2a means, if I consider the midpoint of these two from your first PUC concept, you might have studied that two charges, equal and opposite charges, exerts force on each other, but at what? The center of the body, is it? So this is what you might have studied. So center of the mass, if I take, they exerts force on each other at the center of the mass. So if I consider the center of the mass, from the center to one charge it is a, the distance, and from center to another charge the distance is a. So a plus a, it is 2a. So distance is always 2a, and the direction is also given for the electric dipole. It is from negative to positive charge. It is just for our convenience which this has been given, and this is something called as electric dipole. So it is nothing but what, yeah, it has got two equal and unlike charges, so and with a small separation of 2a. Now tell me, what is the net charge of this dipole? The net charge on this dipole is neutral, but will the electric field be equal to zero? No, they will be continuously producing electric fields around them. Electric field will never be zero, but the charge on these two will be zero. Is this clear? That is, they both are neutral together. Next, going to the representation of this, what is a dipole? In the sense, you have to and the dipole is firstly it is represented by p. Okay, and what is it? What is a dipole? It is the product of one charge, any one charge, and the dipole length, so the distance. So what is it? It is a product of charge and the distance, so q into 2a. So what is dipole? Here you can see that any one charge you take, it is a product of one charge and the distance between them. That is something called as dipole, and the SI unit of the dipole is coulomb meter. So yes, if I consider a, this is a distance, and q, it has got a charge of coulomb, so SI unit of coulomb it has got. So here you can see that dipole moment is a vector quantity, and its direction is always from negative charge to the positive charge. Next, going to the big derivation, which is very very important, and you will find in every question paper this derivation would be asked. It might be in every question paper or alternative question papers. Like if I consider 2018 question paper, they have given this dipole derivation, or 2020, like that. No, as this is very much important, you have to understand what is it. Okay, children, now if I consider electric field due to what? Dipole. So you studied about what is dipole? Yes. So it has got a positive and a negative charge. So equal and unlike charges you have got with a distance. So this one produces electric fields around them. Yes. So the total electric field of these two is how much they are asking you to derive one equation. But what is the condition? You should derive the equation for the electric field due to dipole only, but at the axis. So if I consider this is the dipole, on its axis somewhere you have to calculate, not here, not here, not somewhere here, but on the axis only you have to find the electric field of what? Dipole. So what is a dipole? It is something that you have got a positive and a negative charge. So hope I have made it very much clear to you. Coming to the diagram over here, one thing, firstly what you have to do, so I'll be just telling you, you keep one notebook with you. Whatever I say, you just follow that and write it in your notebook, so that you will get to know what to write and what not to, and from where you have to start and where you have to end with the diagram. Now, if I consider dipole, they are asking for a dipole. First, I'll write a dipole now. So, dipole, this is your dipole where it tells you one negative charge is there, one positive charge is there. And the distance between these two, as I told you, its force will be concentrated on the center of mass. No, so if I consider this is the center of mass, the distance from the center of mass to one charge is a, and if I consider center of mass from another charge, the distance is a. So together you can see that it's given as 2a. Okay, so this is what you understood. This is your dipole. Next, let us come to this portion of the diagram. So they are asking you electric field due to a dipole, is it? So this one would be producing one electric fields over here, one electric fields over here for the two charges. Now if I consider this point to be as P, I want to calculate electric fields of the whole dipole at which point P on the axis of this dipole only. Okay, so this point I would just choose. And why do I choose only this point? Okay, I can choose somewhere here also, but while you're studying and you're just studying to uh, write this derivation in your examination correctly, just look at this diagram, do not get confused, do write or learn whatever is being given here, and don't go to try something and all and it'll be a mess up in your examination. So now on to your right hand side only, you just take a point, and if I consider these two dotted lines, it is telling you that it is a electric fields of what? Charge A and charge B. So charge B, electric fields, it is going outward, that is a positive charge, and it is radiating outward, it means. So if I consider EA, it is radiating inward towards the negative charge. So this is the point where you have to find the electric field, total electric field. Now I have another thing to tell you, that can you see the distance over here? That is something called as R. So just take center of the dipole to the point, the distance to be as small r. Hope I made it very clear to you. This is the pictorial representation of this derivation. So what is the derivation? What kind of question you may get? Derive an expression for the electric field due to dipole at the axial point. Okay, now they are telling you, let us go to the derivation. Let P be a point on the axis of dipole as shown. Okay, now if I consider electric field at point P due to positive charge, so this charge I would take now. And now what am I doing? I am taking individual charges individually and writing electric field equation for that. So E, electric field of this positive charge, is equals to, what is the formula of electric field? 1 divided by 4 pi epsilon naught q divided by r square. No, so what is this r square? Distance between what all? It is distance between the charge and where it, which point it is producing a electric field. So if I consider this point, okay, what is the distance from B to P? It is R minus A. So this is your distance. So if I cancel this distance by A, you will get only this distance, that is BP. So that is why I have written R minus A, but the whole square which was given in your electric field itself. Now if I go to electric field at point P due to negative charge, if I consider this negative charge, the distance would be from this to this point. So from the midpoint to this point, you have got the distance to be r. And what about the remaining thing? So it is a. So r plus a. So you're understanding, a plus r gives the total length of these two. Okay, so you have got 1 divided by 4 pi epsilon naught q divided by what? R plus A. So the whole distance, the whole square. Now what you're going to do, these are the two electric fields of the individual charges. No, so what are they asking for in the question? To find the net electric field of a dipole. So just do, what is it? Just add it. So one thing I have forgot to write here, negative sign should come. So as this is your negative charge, so negative sign should come here. So make a note of it. Now you have to add it algebraically. E plus E of charge Q and minus Q. So now what you're getting, E is equals to Q divided by 4 pi epsilon naught is common. So Q divided by 4 pi epsilon naught, Q divided by 4 pi epsilon naught is common. So negative charge is, negative sign is there. So what you're going to write? What is the remaining thing? 1 divided by 4, 1 divided by A minus R minus A the whole square minus, why minus sign? I told you, remember, negative sign should come over here. So minus 1 divided by R plus A the whole square you just put. So what you're going to do, you're going to cross multiply these two. So when you cross multiply, as this goes over here, R plus A the whole square, so it is like A plus B the whole square, you just split it. So R square plus A square plus 2RA minus sign, so this minus sign would be like that only, into R square plus A square minus 2RA. So as this comes over here, so how is this equation? It is A minus B the whole square, no? So like that you're going to again exaggerate it. So divided by, it is like a square into b square. So how you're going to write it? So a minus b into a plus b form you're going to write in the denominator, but the whole square. So square is there, no? So square you're going to write. So now what you're going to do, this negative sign you just multiply to every term over there, and you would get r square gets cancelled, a square gets cancelled, and what is the remaining thing? It is, you should add these two. You cannot cancel this. It is 4r a you would get. Now what is it you have to do? So what are the remaining things you'll be writing? You will be carrying it for every step. So now what is that you're going to write? So I can split this 4 into 2 into 2, it is 4 only, so I have split it. So why have I split it? I have taken q also inside, because 2qa, what is this 2qa means? It is a equation or the formula of dipole, no? So 2, so q charge into the distance of the dipole q to a, it is p. So instead of q to a you're going to write it as p, and this 2 comes over here. So now you have got 2pr. So 1 divided by 4 pi epsilon naught 2pr divided by r square minus a square the whole square you have got. So now if I consider the distance, that is r, is greater than a. So say if I see this diagram, r is greater than the distances between the center of the mass and any of the charge, then this a becomes unit, it becomes 1, so it vanishes, it says. So this a square vanishes, and what do you get finally? It is 1 divided by 4 pi epsilon naught 2p divided by r cube. So how did you get r cube over here? I would just explain it to you. A square is not there, so when a square is not there, r square the whole square, it becomes r to the power of 4. So here one r is there and r to the power of 4, no? So 1 r and r to the power of 4, for that you cancel it out. So what is remaining? 2p, and this r has been gone in the numerator, and in the denominator you will be having r cube. So the total electric field of the dipole is E is equals to 1 divided by 4 pi epsilon naught 2p divided by r cube. So this is the formula for the electric field of a dipole at its axis. So this is what we have studied in our today's class. I hope that you have understood it and the concepts are very clear to you. Just as this is your PPT representation, okay, PowerPoint presentation, you have to just imagine and concentrate a little bit, and you will understand the concepts very much clearly. So I think I have cleared all your doubts. In the next class I would be teaching you about the electric fields. Due to dipole itself, there is another derivation which is not at the axis but at some other point, which is something called as equatorial point. So which it is perpendicular to the axis. At that point let us find out the electric fields, but due to a dipole. And then let us go continuing with the other concepts of this chapter. And finally I would do the numerical problems also. It is very easy. Once you understand the concept, it will be a cakewalk to you. And I hope I have cleared all your doubts. And if you have liked the video, understood the concept, only then please do subscribe and like my channel. And thank you.